Assalamualaikum and hi to everyone. Thank you for watching my video. So in this video, we continue on the previous video that we already learned about the entity and attribute. So this video will talk and discuss about the relationship in the entity relationship diagram. So relationship is an association between the entities that we have in our DFD diagram, which is defined by a diamond shape symbol in an ERD. So given a name that describes its function is referred to the relationship name is active or passive verb. So how we want to give a name to our relationship in our ERD diagram, you need to use the verb. So example here, we have author as the entity, and we also have the book as the entity. So both are the object. So the relationship between the author and the book is author write the book. So the verb we can use is write. So an author writes one or more books. Okay, if we want to sort that kind of data in a table, so we need to think in logically that one author can write more book. One book can be written by many authors, one or many. So that's the relationship between the author and the books. So it shows the relationship between entities, author and entity book. In the next point, we look at the relationship one many. So one to many relationship. So one refer to number one and many refer to the capital M. So maximum one X for each Y and possibly many Y's for each X. So that is the definition of one dot M relationship. So so it will show like this one. We have faculty. So this one is entity. So one faculty, for example, we have the FSKM. So, and then we have the course as another entity. So the relationship there, we can put offer. So faculty offer many course. So one faculty offer many course. Okay, example, we have faculty FSKM. And then FSKM will offer many course. What kind of course? And then each course have their own course code. So faculty have the name. This is the attribute of the faculty. So faculty name, for example, FSKM offer course. In a course, we have the course code and course name. And the faculty name. So this is how you can draw the relationship between entities with the attribute too. So next, we have the Crawford model and the chain model. So in the Crawford, we use this kind of symbol. So this is referred to one and this refer to one or many. So painter, paint one or many, painting. Painter paints painting. So if you want to use the chain model, then you use this symbol. Otherwise, you can use this symbol. Please make sure if you want to draw using the chain model, so all the symbol must based on the chain model. And if you want to use the Crawford model, so make sure all the symbols are based on the Crawford model. You cannot mix both model. Okay. So this is example of one to many, one painter may draw many painting. So in your database, it's based on a table. So let's say we have a painter as the entity. So we have table painter, and then in a table we must have the primary key to refer to that painter. So primary key, painter number, and then there's no foreign key for this example. So these are the attribute. We have the painter last name, we have the painter first name, and we have the painter initial. Okay, let's say we have Rose, Itero, and Julio. And then this is the painter initial. Okay, the next part, if we base on this one, we have painter and we have the painting. So in the painting, we have the painting table. So inside the painting table, we have the attribute. So we have the painting number as a unique part as the primary key of this table. And then we have a column painting title and painting number, painter number. So this one is the attribute for the painting, and this one is the foreign key that refer to the painter. So from these two table, okay, you can see the relationship that this painter with name Rose refer to painter number 1, 2, 3. One painter have many painting. So this Rose paint Down Thunder, also paint the Vanilla Roses to Naui, and also paint the Hasty Exit. One painter may have several painting. So these are the relationship from the ERD. Then you can translate into the database table. Okay, you already know about one to many, and next is about the one to one relationship. So if you find this symbol, so that means maximum 1x for each y and 1y for each x. 1 to 1. Okay, should be rare in any relational database design if we only have 1 to 1, but it is still logic. So a single entity instance in one entity class is related to a single entity instance in another entity class. So still entity and entity could indicate that two entities actually belong in the same table. Okay, so the relationship here, we have manager and we have branch. So one manager only manage one branch. Okay, basically, we only have one manager for one branch. So attribute for the manager, we have the manager ID, manager name, and so on. Okay, this is symbol of the relationship in the chain model. So 1 to 1. So one manager, one branch only. So branch is the entity and it also have their attribute. So employee can manage only one branch at one time, and each branch only has one manager. Okay, this is the logically one branch only have one manager. And one manager only manage one branch. So these are how we can represent the relationship between the entity manager and the entity branch. Okay, so this is in the ERD model diagram. Another example, we have a professor and the department. We have one professor chairs one department. Yeah, actually this one is some sort like the previous one, one manager, one branch. But in terms of the professor and department, only one professor that become a chair of one department. So this one is the in Crawford model, and this one is for the chain model, diamond, and we have this symbol. So this one is referred one and only one and only one, or one. Okay, so based on the relationship on the ERD, you can translate into your database table. So you can have table professor, and the primary key is referred to the employee number of the professor. And then we have the foreign key for the department code, because one professor manage or chair one department. So let's say here we have table professor, so employee number here, department code, professor office, professor extension, professor high degree. So this one are the attribute of this entity, professor. Okay. So based on the ERD, we have professor, department. So department another table, so department code, department name, school code, and so on. So in this table, we put this employee number as the primary key. In this table, we put the department code as the primary key. So in this table, the foreign key for this relationship, in order to show this relationship, so the foreign key must refer to the department code. Okay, department code here. And at this table, the foreign key is the employee name to show the relationship. So let's say here what we have. Here we have a professor (103). There's no, okay. Let's say we have here 114. Okay, 1014 here is the employee number. It attached to the department account. Okay, department code is account. So based on this point is relationship to account, okay, employee number. So 1 to 1. Okay. We know one to many, one to one, and then now we have the MN. What is MN? Possibility many X for each Y and many Y for each X. Okay, so must be avoided because they lead to data redundancy. In this kind of relationship, you need to avoid, because later on in database, you will have the redundancies of the data. So please avoid this kind of relationship. So this one can be implemented by breaking it up to produce a set of one to many instead of many to n. You can break it down and make it to be a relationship one to many. Okay, can avoid problem inherent to MN relationship by creating composite entity or bridge entity. Okay, this will be used to link the table that were originally related in a MN relationship, composite entity or bridge entity. So the composite entity structure includes as a foreign key at least the primary keys of the table are to be linked. Okay, this one is many to many. So basically we try to avoid this part, or we can create another entities, or we call as the bridge table in our database in order to solve this issue. So let's say here what we have. We have book and we have author. many books have many authors. Many authors have many books. So many books are written by many authors. Many authors. Many authors write many books. So that is the relationship. Yeah, a book may have more than one author, and an author may write more than one book. So that is the relationship. If you want to create something like booking book or so on. Okay. So inside the book we have the ISDN, book title, and so on as attribute. And the author we have author ID, author name, and so on. Okay. So here we have many to many. So written is based on the this one is the composite entity. We combine the author ID and the ISDN as the composite key in order to identify what this book is belong to, which author, and author is belong to which books. So we need to create a new composite entity or bridge table. So this is how we represent the ERD. We have student, class. One or many student has many classes. So here we have the browsers, accounting, browse, intro to microcomputing, intro to the statistic. So Smithson also have accounting subject, also have the microcomputing, intro to statistics. Is just only you and your classmate. Okay, you and your classmate refer to the students. So many students have many courses that being registered or many classes. So this kind of relationship cannot be implemented because it will lead for the data redundancy in your database table. Okay, look at this example. These are the redundancy. Browser. Smithson. A lot of data that being redundant. When based on this symbol, when you translate into the database, it will look like this one. So we have table student, we have table class. So table student, we have student number, student name, and class code. Primary key here, we have student name, student number. Okay, we cannot just only have the student number because we may have the redundant student number. So we need to student number plus the code. Okay, and then the same goes to the class. Okay, instead of using the class code only unable to detect the right data that you want to search. So you need to add the class code with the student number in order to identify the right data that you want to search. So these are the redundancies here that we talk about. So we can change the many to many relationship to one to many relationship. A student has class. Many student has many class. So we change from this relationship. We can put student registered to enroll. So enroll shows in class. So we change this logic into another part, from many to many to one to many, in order to remove the redundant data. So we create another entity or that we call as enroll. So another table need to be created. So it look like this one. Student has many class. So here we put student enroll class. So here are the many to many relationship. So what we do right now, instead of only we have this table student and table class, now we have another table that we call as table enroll. So student table, we have student number and the name. Okay, there is no foreign key here. And then we have enroll. Okay, for enroll, we have using the class code plus student number. So class code, student number, this one is referred to the student here. Okay, and then we have the attribute enroll grade. So the database designer has two main options to define a composite table primary key. How to define the composite the primary key? Okay, we use the combination of those foreign keys or create a new primary key. You can create another part is about the enroll ID, or you just can combine the foreign key from the others table. So on. Okay, class code and student name, and class code and the student name are the foreign key. So foreign key reference the primary keys in the other table of which it has the relationship with. So another table that we have is the class, and the class we have a class code. The foreign key is CRS code. Okay, the CRS code for the class. Okay, and this part is another course code, course code of this class. So now we change from many to many, we change to one to many. So this is how you should do when you want to come out with your ERD. Anything that with many to many, you must create another table or composite entity, or what we call as the bridge table. So that's all for this video. So hopefully you're able to learn on how to create a relationship and then translate from the ERD to the database. Learn the basic logic on how the process of creating the database being done. So next part we will learn about the cardinality. So thank you and Assalamualaikum.